Creating a heat exchanger with AutoPIPE Vessel is really simple, and getting it imported in our OpenPlant model is even easier using our import tools. I'm Vivian Jennings, Application Engineer for AutoPIPE Vessel. Let me guide you through the whole workflow, starting from the beginning.
File, New, we select Shell and Tube Heat Exchanger, then OK. The TMAP type is AKT with a pull-through floating head. We'll be using SME8 division 2, using WRC for the openings, the root area for the bolts, and the optimized design so that the software helps us all along the way. Next, we input the internal conditions, both tube side and shell side. And temperature on tube side is quite high, it's steam, and there's some corrosion allowance. Then we click on Next. There's a bunch of load combinations already there, created by default. Let's remove some to speed up calculation. Then we have an external diameter of 1890, the first saddle at 1600, an axis ratio for the elliptical head of 2, horizontal vessel, then the diameters of our tubes. For inlet and outlet, this is shell side, and then tube side. Integral hub is the type of body flange, and then we input the gasket material. We don't want our shells to be split. We just say 8 meters and we click on Next. It's an AKT type, so we selected correctly. The construction standard is going to be TIMA, even though I have a bunch of them, and the class is R. The pitch is triangular, 1.5, diameter of 30, and a straight length of 6541. Then a bundle of 12. We will be having 5 support plates and a wheel location of 50 from the reference line. Click on Next. It's going to be 2 paths with 600 tubes. Click on Compute. We have Layout and then Next. This is our report configuration. And then we're going to assign materials, but I'm just going to use the ones by default. So I just press Next. And here I have my preliminary AKT. Let's adjust the length. So this one is going to be 6 meters. And the cone, we are going to have a length of 910 and a knuckle at the top. That's it. Now let's go for the nozzles. So N1 is located at 2040. We have 2 inlets, so let's copy the second one from here, N1, 2. It's going to be a 5090. That's okay. Then we have a small nozzle here. Insert nozzle. It's called N5 with an NPS of 6 inches, located at 300 with an orientation of 90. It's at the bottom. With a goose, we insert the radius and length. Then we add the flange. Well, we make 6 nozzle flange. And then the material for the nozzle and for the pad. And here you have it. Let's adjust the position of the last nozzles. So 6740 and this one at 7560 and 7560. So this one is not long enough. Let's just change that. So let's adjust these lengths. So this one is 200. This one is 927. And that's it. Now we're ready to run calculation. So that's it. Now we position the next saddle. It's going to be at 4 meters. And that's it. Double click to refresh it. That's okay. And ready to launch. Yes. And that's it. So we can see the, we can take a look at the reports. So you can see we have a sketch, a summary, and all the calculations. In AutoPIPE Vessel, the reports are known for being really straightforward, self-explanatory, and step-by-step. So you can see it. We have the images, all the data, and then the equations from the code and the code reference too. So they are really useful and meant for you to understand the calculation and find a solution as soon as possible. Then what happens if we want to create our model? We just generate drawing and click on OK. And that's it. Now let's visualize it by clicking on the eye, and they will all appear on the screen. We have the drawings here. We can see the two saddles, the longitudinal view with the nozzles, the transversal view. This is the body flange with the bottle cover. These are the two body flanges that are along the, that sustain the tube sheet, the bundle, the floating head, floating tube sheet, baffle distribution. Everything is customizable in AutoPIPE Vessel, and even the tables. And we have a second sheet here with all the support plates design and the channel and the position of the nozzles. And of course, we have our 3D that comes here. Just click here. And there it is. And it has some degree of intelligence. And of course, all the internals are also there. Now let's go to OpenPlant Modeler. You can see here the whole plant with several vessels, columns, or coolers, and even a tank. This is the finished rendering, but let's see how we did the heat exchanger import. In the menu, we click on Place from Cell button, and then we select the reboiler we just created. Then we just have to place it. When we make it transparent, we can see that the bundle and other internal accessories are still there. Now, let's reconnect it to the piping circuits by creating the bends and straight pipes that correspond. In the Piping tab, we can select the types we need. You can see how intuitive the process is. Inlet nozzles located at the top of our vessel also need to be connected, following the same simple procedure. Now we can see the final rendering of our imported vessel, perfectly connected to the piping system of the rest of the plant.
Wasn't it easy? Let us be part of your team. You can find more information in the description below. Thanks very much for watching.